I'm Matt Godbolt.
And I'm Ben Rady.
And this is Two's Complement, a programming podcast.
Hey Ben.
Hey Matt.
I don't know what we're going to talk about today. I'm feeling kind of like we should record a podcast, but I've had a long day of talking to other people and I'm a bit low energy. So get me to let's talk about something interesting that's going to get me excited. What do you got? Long pause. What are we going to talk about?
Well, we could talk about Make.
I love Make.
That's
I was
all.
very,
That's all.
very unfashionable to like Make, but it's arcane, it's awkward, it's spiky to use, but it's good at a particular job, and that is its primary job is to already be installed on any computer you might want to use.
That is the primary feature that Make has, is that you already have it whether you want it or not.
Very, very likely you have it. I don't actually know nowadays if an Ubuntu, say, machine comes with it, but I would not be surprised to find that it is already on a system, even if I went for a minimal install. It's so base. But yeah, the thing I like about Make is it's sort of self-bootstrapping. Once you've got Make, maybe curl. Oh no, you see, now we've got two things. But all right, okay. But with a very minimal set of things, Make can build everything else that you need from it. So maybe you don't like Make. Maybe like me, you like to use CMake and Ninja and other magical, clever things to build your software. But Make can make those things happen for you. Make can download the binaries and put them in a bin directory and make sure that they appear. And that is my preferred way of distributing source code for the projects that I'm involved in. And it's it's one of the things I covet the most is the feedback from new members of my team or folks who are just interested in the code that I've got. That they say, hey, I just git cloned your repo and I typed Make and the whole thing built just fine out of the box. I didn't have to think about anything. I didn't have to install anything. And I'm like, yes, that's how it should be. That's how software should be.
Yeah, absolutely. I love Make because it can be used as a general purpose tree of tasks thing doer, which also can be run in parallel if you like. And with that, and as you say, it's just everywhere, right? Like you almost certainly have it whether you know it or not. And so you can get this sort of magical developer experience where you clone a repo, you run Make, maybe it prints out a little help menu of targets for you, which you run Make, and then you just have everything magically installed, and it all just works. And it's like, oh, how do I run my test? Well, you write Make test. Well, how do I start up the system? Well, you run Make start or Make run or something like that.
And to be absolutely clear here, Make here could be the thing that's actually doing all of the crazy dependency tracking and all that. But it also could just be a kind of front end to another tool that says like, hey, I'm just going to make sure the environment is right to run the rest of the system, so you don't have to remember which weird packages you need to install and put where. And again, so I guess a corollary to this is that where it is possible, I personally love to have sort of hermetically sealed dependencies. Like, don't assume, except for maybe curl, because, or wget or whatever, don't assume that somebody will install a whole bunch of random packages globally in order to support your project locally. That's kind of, I mean, we're also, I should say, we're very lucky that the situation that we're in, certainly at work in our day job, is that everyone has a monoculture of operating systems. It's a big deal when we move the company forward to a new version of the operating system. And so we kind of know everyone's on this particular version of Linux. But even in my personal life, some of the projects I've got assume some kind of Linux, and then they mostly work on that out of the gate. Maybe I'll say, okay, you go and get Node. You get Node, and then I'll check that it's the right version of Node, and then I'll run it. But it's still I mean, behind the scenes, NPM is going to be doing all the package management or whatever, and all locally and hermetically. It's not global. But make is the thing that's making sure that you have got the right version of Node and NPM, and then invoking them in the right way. And then as a user, you don't need to know that. Make run.
Right.
There you go. It's running. Make start, as you say.
Right.
And I think it's for somebody who doesn't quite know what's going on with the software and how to build it. It's just nice to have a convenient API. I don't know what it's not an application program. It's like an application developer interface, right? It's an ADI.
Yeah. Well, it's a, whenever you build automation like that, it serves two purposes. One is it just makes people's lives easier, full stop. It also serves as a completely authoritative and correct documentation of how the process works.
Right.
Because that's the only way to do it, is to run, make tests. Like, that's the only way that we have to run our tests, right? So if you want to know how to run the tests, you can read what that does and you will know for certain. And you can version it with your code and change it over time. And you can have pull requests where you discuss it and be like, oh, maybe we should optimize it in this way, or maybe we should offer this kind of flexibility for it. And it doesn't become this thing that you just have to know if you work on the project, or, living in a rotten piece of documentation somewhere that no one's updated in 3 years or something like that. It's like, oh yeah, how do you run the test? Well, you pull up Ben's bash history and you find all the commands that he ran to do this, right?
You and I have worked with folks that have got their Google Doc of shared crib sheets of this is how we do that thing, and they paste from it into their terminal, and it's not something I enjoy, and it's not something I would like to have in my project. And I guess one of the solutions to the hermetic makefile thing that people go for is something like Docker, where the steps to get the environment set up are part of the Docker container. And I guess that's arguably far more hermetic than the stuff that I'm talking about here, because it's, very much contained and localized. There's no external state can escape into it without a lot of work. So maybe that's a slightly better thing. But in my experience, Docker ends up being a millstone in that environment. I would much rather kind of rely on, everything's in a .bin directory inside my, git ignores .bin directory, and that's what the first thing the makefile does is put that .bin directory at the front of the path, and now it's like, hey, anything we need should be in here, that kind of thing.
Yeah, I found myself, especially in recent years, leaning much more toward projects that offer a sort of single binary download for their tools. A lot of the HashiCorp tools have this, and there are other projects as well, where you can just go fetch this thing, unpack it for whatever architecture it is that you're using, and there you go. You've got your single binary that you can run.
And that factors nicely into this sort of makefile thing, where you're like, okay, if .bin/terraform doesn't exist, then this is how to get .bin/terraform. Curl the HashiCorp endpoint and then pipe it through gunzip and then chmod it and put it in .bin, and then we're done. And you're like, there you go. All right, now anything that needs Terraform will run that version of Terraform, and it came down. And then maybe you put the version number in there as well, so that you can bump the version, and it just automatically downloads the next version, and everyone's on the same version of Terraform, all that kind of good stuff.
Right. And this all gets back to make, because what is make good at? But it's like, make this file exist, right? Well, how do I make that file exist? Well, here's the target that describes how you bring that file into existence at this location that you want it to be. And that can be a dependency of another thing that needs that file. And that's just essentially what you're doing when you're, it's like compilation is in this context is just turning curl into bits on your disk instead of compiling a file into bits on your disk. But it's all sort of the same thing in a way.
Yes.
It's funny. And I actually, so this is something that I've been struggling with for the last week or so, actually, because I had an engineer on my team conduct a little experiment with his M2 Mac, where because right now all their development, like you say, is on Linux. We use Mac as sort of a dumb terminal, essentially, for a lot of the things that we do, which is a little bit of a shame. They are, pretty powerful machines, but that's just how they're set up. And all of our CI runs on Linux, all of the servers that we do run on Linux, everything else. But just out of curiosity, and maybe I shouldn't have asked this question, I had him go and run our tests on his Mac, and they ran in half the time. And I'm like, well, we're moving to Macs.
on a laptop M2.
Yes.
The tests run faster than on our big beefy servers that we connect to.
Yes.
Holy smoke.
like a lot faster. And so, and this project is in Java.
Right.
And so moving it to a Mac is not a totally insane idea.
Right.
But one of the things that I will definitely have to reconcile if we're going to do that is the sort of, GNU BSD mismatch that you get when you have shell scripts or other things that are written for Linux, and now you're trying to run them on a Mac, and, grep is not quite the same, or some other thing is not quite the same, and now I have to do this. And I'm trying to figure out, like, okay, there's no way I'm giving up on this level of automation that we've talked about, right? Like if the choice is move to Macs and then do everything manually or stay on Linux, we're going to stay on Linux.
Yeah.
Right? There's no question.
Yeah.
Right. But one of the things can definitely happen when you do this kind of stuff is that you start to accumulate these like these things that you build, right? Make targets that you build, scripts that you write, and you use them a few times and maybe they're useful, and then you maybe never use them again, and they just sort of hang around. And I think unlike source code, where you're maybe more frequently looking at it and you're sort of thinking about like, okay, can this be used? Well, I've got my main function or something, and it's like, well, if it's not a dependent of that in some way, well, then why do we even have this code, right? Whereas with, some of those little utility things, you maybe don't notice that or don't think to ask that question. So I'm kind of hoping to think about this as like, okay, well, if we're going to move over to, OS 10 as our main development environment, that's going to force me to reevaluate the worth of every single one of these little utilities and things that I built.
Because now there's a double cost to it. There may already be a cost because if you went back to it right now, it may have rotted in some small way, but it's only it should be within spitting distance of working, whereas there's sort of an unbounded amount of difference between the version, as you say, of grep or some command line flag that you're like, there is no equivalent on BSD. What are we going to do here?
Yeah, and maybe the answer is you just delete it because you haven't used it in 6 months. And if you need it again, well, the code's not going anywhere.
Yeah,
you can go find it. You can dust it off.
Spoken of this before. The immutability of like the history of source code. It's there to go and find again.
Exactly.
So
exactly.
Maybe is that an argument for those funny little tasks leaning even more into the like make is purely a thing doer and say the things that it does are very, very, very limited. They're restricted to running things like Python scripts for which we know are maybe more portable. Maybe I'm saying that out loud now, but now I'm not so sure because I remember having this debate with Java and another colleague of ours a way back wanted to do a similar thing with Java when we were working on a system around the time actually when we were discussing whether it was C++ or Java, which I think was a long while ago. But
that was
yeah.
Right.
Anyway, that time, and the sort of he was making the same point. Like I would love to be able to run this on my on a Mac or just not my my desktop machine, and Java gives me that illusion, and I'm like, that's fine. But the day you come to me with a bug that's like, this weird native library that we're using doesn't work the same way on Mac as it does on Linux is the day I say stop doing that because, with the particular project we were talking about, that might have been a real possibility, some esoteric networking thing or some, pub sub mechanism that was like had a native backend, that kind of feel. Whereas I think the stuff that you're talking about is more like AWS interaction, which seems like it might be the same across the two and HTTP libraries and things.
Right.
So, there's a little bit of, I suppose I took the other side of what you're saying, which is like, well, no, I guess it's not actually. You said if there was a choice between, okay, we can't do this we have to do this manually or we have automation in Linux, you say, well, we just have the Linux. We can't do it on the Mac. But if you can get it to work on the Mac, then you would. Now that makes sense. But yeah, it's that thing of like not knowing where the sort of cross-platform troubles lie until you run everything. I mean, I know this is going to sound weird, but what if you had tests?
Well, yeah. So, I mean,
you're laughing.
We started out this episode with a dearth of ideas.
Yeah.
And now I'm looking at the clock going, be like, if I start talking about this, we're going to run out of time. But
I think we're good.
But yeah. So, I mean, I have definitely done things in the past where I had a lot of shell scripts that I needed to test. I wound up testing them in what I thought was a fairly novel way.
If I remember, the way that you were testing might actually not solve the problem that we are seeing here.
No, it wouldn't. It
Right.
would
Do you want to talk a little bit about? Let's segue briefly into your way of testing shell scripts.
Yeah.
And then we can talk about why it's a great idea, but it doesn't work in this instance. It
doesn't solve this problem. Right. Yeah, exactly. So the way that I did this was, and I know that there are testing libraries for Bash that exist.
Like actual regular testing things
yes.
that work
like
the way
if you want to write like a regular unit style test for Bash, you can absolutely do that. I've tried those things. I find them kind of unrewarding. Like I don't really see the productivity gains that I get with other approaches to testing when I test Bash that way. And maybe it's just that I don't know how to use them effectively.
Right.
But that has been my experience.
Maybe you shouldn't be writing that complicated stuff in Bash in the first place, which is a kind of the argument about the Python thing that we just talked about. But let's assume that you've got enough little bits and pieces that are like nothing more than grep and tail and a few other bits and pieces. And it's like, well, why would I? This is perfect. Go ahead. Sorry, I keep interrupting you.
No, it's good. Well, and so like the approach that I took here was to kind of treat Bash as a kind of difficult to work with text-based interaction protocol. Right. So I wrote a bunch of Python that generated Bash. And I unit tested that Python. And I basically treated the Bash like, okay, this is just the protocol that you use to interact with the operating system, right?
And so your tests were done at the level of the interaction with the operating system through the strings that would have been passed to the interpreter.
Exactly. And so what this wound up being is you'd have a Python program that you could run, and it would basically just be like, run this Python program and then pipe it into Bash, because it just outputs Bash. Right. And then you can unit test that Python, and you could do fun things like you could just write the output to shell check, and then it'd be like kind of almost an integration test of the Python to say like, okay, did I miss any unit tests here? Right? Is the Bash that I'm generating no good? And you could compose them together, so you could have like a Python function that generated a Bash function, and then you could call a bunch of those functions to generate a whole script, and then call pipe together different Bash functions to do different things. And it was kind of clever and interesting, and it gave me what I wanted in terms of the confidence that I needed.
To know that you were generating the right interactions with the operating system, which is perfect for what you were doing then. But what we're really talking about here is trying to develop confidence that the interactions with the operating system are in fact the correct interactions and have the same effect in both operating systems. And that's almost an integration test definitionally.
Yes. Right? I mean, I can't, and there might even be differences in the behavior that would otherwise be acceptable. And it would be very difficult to know what those were a priori and say, and it wouldn't even necessarily make sense to do that. It's like, if you're in a world where it's like, yeah, we just deploy on Linux and develop on Linux, why would I do anything that supported BSD? That wouldn't make sense. So you wouldn't design it that way.
Yeah.
Right. So, probably the real answer to this, and I thought about this too, is don't try to lock yourself in a room with some box of pizza and a laptop and just hack this out. And all right, this is going to be the weekend. When you guys come in on Monday morning, we're going to be on Macs, and right now we're on Linux. The way to do this, especially because the project is in Java, is to try to move more of those operational tasks into the Java world. And then when you have shrunk it down to a level where you're like, okay, it is just make and a couple of other little wrappery things, and I can very quickly verify, I can clone I can do exactly what we talked about a few minutes ago, which is I can clone the project, I can type make, and it'll run, and if it works, it works, and if it doesn't, well then okay, try again. You missed a spot.
But this is like you're moving the functionality out of the Bash and into the rest of your framework. You're treating it as a first-class citizen inside the rest of the code base, where you have your libraries for interacting with files and logs and things that you already have, and instead of using grep, you're like, well, okay, I guess I will just use a regular expression. I mean, seems to make sense to me. And yeah, if you already have that infrastructure around and you don't need it to work outside of that infrastructure, makes a lot of sense, right? If it's involved in the build of that stuff, obviously you've got a bit of a chicken and egg situation if these little tools are involved in it, but I think that's not likely to be a problem. And you mentioned again, like the HashiCorp style, of like having these little executable binaries that are like themselves. For external dependencies, we've done that in a couple of places on our projects. We've got a couple of like helper binaries that would have potentially started out as Python programs themselves, which then entail all of the fun and games of like, well, how do I make this an executable? And there are ways and means of turning a Python function or a Python command line tool and its dependence and all of the interpreter and everything into what looks like a binary, except it's just a giant tarball that unpacks itself into temp and then runs. It's all the bad things you might imagine that happen. It's clever and it works, but it's not great. We rewrote that in Rust as an example of relatively. We wanted to learn some Rust anyway, and we did it as a Rust project. And Rust is relatively straightforward to then do a static compile, and we ended up with just a little binary. And then we're like, okay, well, we versioned that, we chucked that somewhere, and that's one of the things we curl down in our make file. And okay, it's divorced and it's separate from our project, but if it's part of the build itself, or it's useful to work even when you've kind of broken your project and you can't do anything, but you want to be able to like go, help, I'm debugging and diagnosing something, and the last thing I want to do is have to rebuild everything, then it's a convenient little way of achieving that. So I've just gone round in a big old circle there. You mentioned like taking a long time to talk, but
yeah, no, it's funny that like I don't really hear people talking about this as much as I would expect. The sort of like deployment impacts and the automation impacts of the decisions that you make when you're building these tools, especially tools that you intend for someone else to be used. Like I always cringe a little bit when it's like, oh, here's this great tool that does this thing. Oh, how do I run it? Well, you get this Docker image and you run the Docker image, right?
Again,
like,
I will.
Could you really not have done better than that?
You know,
really?
I don't. You know my feelings on Docker. I've made them clear here as well. That is one of the few uses of Docker that is maybe okay for like certainly for CI. It's like we are in a very stable world now where I just know that only the things that I said I needed are there, and that makes sense. But I don't see it as a great developer experience. I want it to work as a developer. I don't want to have to work in a pretend copy of my own machine inside my own machine. You know, there's sort of a Russian doll thing going on here, and then there's the issue that like essentially by running Docker you have root on the system that you're running on whether you want it or not, and every file's owned by root, and you want to like punch files in and out, and then you're right. It's just all bleh for developing. And I know that there are ways and means of making it slightly better, but it just feels like, I don't know, you've seen the meme, you know, it works on my computer. Well, we'll ship your computer then. And thus Docker was born. And it feels a bit like that. It's like, well, the build works on my machine. All right, well, let's tarball up your machine. And now Barry's machine.tar.gz is how everyone builds software. It's like, how is this built? I don't know. Now, obviously, Docker definitely has much more of a flavor of we know how it was built. Although there's a whole other conversation about like how easy it is to make a Docker image that isn't reproducible. Because the very first thing you do is like sudo apt-get install these things. You're like, oh, which version of those things did it install? I don't know, the ones that were around when I ran the image.
At that time, yes.
Oh, dear.
I know. That is... that
reproducibility is difficult. But I've completely lost the thread of where we were going with that now, because I got ranting about Docker, as is my way. But I say, you were saying about like other people... If you pull down someone else's repository and they either have a Docker file, or for me, the worst thing is it says, first of all, sudo apt-get, and it lists this gigantic list of dependencies. I'm like, I don't want to install these on my computer. I already have an incompatible version of this thing, and I don't want to install your version of it over the top of mine.
Yes. I mean, honestly, it's sort of like, whenever I see that, it's like going into a store and they've got like, I don't know, pants that someone else has tried on, right? Like it's like, you know, I realize that they're not like cleaning them, and they just fold them and they put them back on the shelf, and it's like, this is how clothing stores work. But it's just like, I don't want to pollute my environment with whatever random packages
and I
you
won't
need
know
for your things.
Why. You know, later on when I run out of disk space or whatever, I'm like, why have I got libbob3 this?
Right.
What the heck is that? And you uninstall it, and you're like, well, and then I hope nothing goes wrong, and then later on you run some random tool and it's like unable to find libbob3.so, and you're like, oh, I guess it was for this. Oh yeah. And I mean, I can't blame it, because software, I mean, certainly in the native world, software deployment and software configuration for C and C++ is not good, right? If you depend on something, then really, yeah, you've got two choices. Either you ship it yourself, or maybe you say you git submodule it in, maybe, and then you say, oh yeah, now you must configure an autoconf and all that horrible ridiculousness to build some random library. Or you tell somebody, oh yeah, sudo apt install this thing. Oh, and if you can't get hold of it, here's some random depackage repository you can add to your apt list. And then, I don't know, some random person on the internet's putting binaries on your computer. I don't know, sure, fine, whatever. Whatever went wrong with sudo apt installing someone else's code. But yeah, it's not easy to solve. I know there are package managers that make this a bit easier. So some of my projects have used Conan, and there's VC package as well. But the thing about both those things are certainly Conan is written in Python and has its whole ecosystem. And the cool thing about Conan is I can install it with Make.
Yeah.
And then I'm off to the races. Now I'm like, hey, no one need know that I'm using Conan, because you download my source code, you type Make, and behind the scenes, Conan goes and solves dependencies, downloads the rest of it, and we're back to where we started in this whole conversation, which is like, it shouldn't matter what it is, but Make starts it off.
Yeah. And like, there's definitely like the sort of like user space versus, root access type considerations there. There's the, at some point something's going to have to depend on some library, and I hope that, the architecture of the system is enough to give you that information. You don't need to, have like there's a decision to be made, and this is like a software design decision where it's like, we could do this cool thing, but then every developer that ever works on this project is going to have this thing installed as root because there's no other way to do it. And it's like, I wish I could say that you should just never do that. Like, that's just unfortunately not true. But you should not weigh those decisions lightly. You should think about what the long-term impacts of all of those things are going to be. Because it's just a tax that you're going to have to pay forever.
Right.
You're never going to unwind that, right? Unless you like move from Linux to Mac and you're like, maybe we don't need this library.
Yeah, right. And then you're like deleting large amounts. Who uses Make, test 3 or whatever, make log tail? And you're like, well, it's got some complicated tail minus F thing in it. But you know what also is good at doing that? I can write 10 lines of Java that'll do the same thing, and it'll be cross-platform.
Yeah.
Write once, run anywhere, as Java is.
It tries to be. One thing I've never done that I might wind up doing as a result of this is these days I'm pretty sure that it is possible to write a Java file with a shebang at the top and then just run it.
Yeah.
And I had never really had the opportunity to do that.
Interesting.
Because most of the time, if I'm doing something like that, I'm reaching for Bash or something like that. But it would be interesting if some of these Bash scripts that I have actually turn into Java. They can use some of the other tools that we have in the project. They could be unit tested in the same way that everything else can. But you sort of use them as you would use a Bash script, right? They're command line friendly. You can pipe the output to
frankly, even if you can't do it with a shebang directly as Java, you could very easily make that generic Java shim app that just runs itself as argv0, but with inside, that .jar in some internal directory. Or more importantly, does make Java -compile and then does that thing, so that you're always making sure you're running the most up-to-date version of that and not being confused. That's an interesting thought.
It's like an option to Java C where you can say, I'm going to give you a .java file. I want you to compile it and run it in a single operation. Right. And so you put that in your shebang, and now you can just kind of write Java like you would any other interpreted language, right? I've never actually done it, so
right. I'm interested to see how you get on, because certainly one thing that I have noticed with the Compiler Explorer startup time is that one of the things we have done, or sometimes do, is run every compiler that we have at startup with just -- version, just to say what version will help, and we do some primitive parsing. We do actually do this offline now. But because of this reason, some of the compilers that we support are written in Java. Like, for example, the Java compiler and the Kotlin compiler and the what's the JetBrains? No, that is JetBrains. Scala compilers, all these kind of things. And one of the more recent, I don't actually know if it caused an outage. Now I say this out loud, but certainly the cause for my phone catching fire with alerts about telling me about failed instances was we hit some kind of threshold where there were, we in order to start up, we run like 4 or 5 of these at once, right? Because it's Node, it's really easy to do its async, but we didn't have enough RAM to run 8 or 9 copies of the JVM, each of which thought that they were the only JVM on the system, and so the thing kept ooming and was being killed, and then that whole node would be killed, and I'd get an alert, and then another one start up and would die again, and you're like, oh no. Yeah. So there is this is just my opportunity to kick Java a little bit. Which I give people grief about for doing, and now I'm just doing it now. Why
do you need 100 megs of memory to tell me what version you are? Come on, guys.
And I mean, of course, I'm very much aware why, because it's a much more sophisticated system than all that. But it does still grate a little bit when you're like running 4 copies of it. And you're like, what? 150 terabytes of RAM? All right, maybe not that. That's a bit excessive. Even for like our beefy work machines, 150 terabytes of RAM might be
That's
pushing
a lot of
it.
RAM. I want a computer with 150 terabytes.
Yeah, that would be pretty cool,
That sounds really cool.
How much? What's the maximum? What's the largest amount of RAM you've ever had in a computer?
1 million.
1 million. That's the largest number, isn't it? I thought it was the largest number. I don't even know how much RAM I'm just going to run that now. It's like one of those things where I've stopped thinking about it for the most part. I know that like some of our production machines have 512 gig, which is like mind-bogglingly large. That's half a terabyte, right? That already is like I don't know if I have that much. Oh, I do have a drive downstairs in the basement that has like my videos and stuff on it that is bigger than that. But like most hard disks I have are not that big.
Yeah. At PrevCo, we had a database instance that had 192 gigs in it, and I think that's probably the most that I can remember.
I'm now just running on this. Oh, I don't know how to use a Mac. I've got a Mac now. I know we talked about this the other day, and the fact that I've finally accepted my fate that the company wants me to have a Mac and all those things. I don't know how to find out how much memory it's got. I've just typed free. This is exactly what we're talking about, right?
Yeah, right.
DF worked for me to say how much hard drive space I've got, and then I did free -8.
Tools are like the bizarro world of GNU, right?
Yeah,
it's everything is kind of the same, but not really the same.
I've just typed memory.
It's like Solaris. Did you ever work on Solaris at all?
Yes, briefly. And Irix was the other one I worked on, which was the SGI one, I think. Yeah. These were all back in the day. I think we've talked. Have we talked about my multi-user dungeon thing? I think we might have done at some point. But I was running certainly in the notes that when we were looking before this for an idea about what the heck we were going to talk about. There's some notes that we should talk about it some more. But for a long while, my multi-user dungeon ran on a borrowed, and the listener will have to imagine me doing air quotes about the borrowing and the legality therein, of a Unix account on a machine that was an Irix machine. So I had to learn how to administrate enough of Irix to be able to run my mud on it. But yeah, these things again, it's funny, isn't it? There's kind of like the kind of like uncanny valley of like, if I'm on a Windows machine, there's no question in my mind I'm not going to try and press the keyboard shortcuts that do the things I'm expecting. But a Mac looks just enough, or feels just enough like a Linux machine that I'm pressing buttons, and then I look like my poor old dad trying to use a computer. I'm like pressing buttons, windows are popping up and disappearing. I'm like, oh, where did it go? Where's it gone?
Yes.
Where? And then like yesterday I was on a call and I moved a window off the side of my monitor to the other monitor, and then I couldn't find it again. And I'm literally on a call with someone trying to debug something. I'm like, you're gonna have to excuse me. I'm gonna quit and restart the program. I'm like, oh no, this is the beginning of the end. Anyway, that's very much like Make. In summary, oh dear, I feel like we can't really finish on any other point now, unless you had anything else. Scott, is there anything else you got for me, or have I just destroyed you?
What have we learned today?
What have we learned today? Make is a great application developer interface. Like if
yes.
ADI of like, you should be able to clone a project and type make build or make or whatever it is you do, and then you've kind of got something which any developer in your organization or your friendship group or your listenership who can go, hey, I know how to build your software. You're like, great. We've learned that Macs and Linux machines are
different.
Same, but different.
Yes.
Deceptively so. And we learned that Matt doesn't know how much memory his computer has anymore.
Yes.
What else would our listeners need to know out of this? This is what they come for. This kind of this deep insight.
Yeah. If you're building a tool that you want other people to use, please give me a single binary for it, because I'll love you if you do.
Yeah, that's a good one.
Docker sucks. That's
well, you heard it here first, everybody.
Docker, I use Docker every day.
I know. Yeah, it's definitely has its place. We've said that before. Yeah. It's like, I think Bjarne Stroustrup has a quote about programming languages, which I think adequately also applies to a lot of things, including tools like Docker. And that is, there are two types of programming language in the world: ones that people complain about and ones that people don't use.
Yeah.
And I think that's true. The only reason we complain about Docker so much is actually it's pretty useful.
Yeah, true facts.
All right, my friend. I think we should call it there. Somehow, we've talked for half an hour on absolutely nothing.
Right.
Maybe to ourselves, because maybe we lost our poor listener along the way.
Probably so. Statistically likely.
It is. Yeah. Actually, it's true, yeah. All right, my friend. Well, until next time.
Until next time.
You've been listening to Two's Complement, a programming podcast by Ben Rady and Matt Godbolt. Find the show transcripts and notes at www.twoscomplement.org. Contact us on Mastodon. We are at twoscomplement@hachyderm.io. Our theme music is by Inverse Phase. Find out more at inversephase.com.